Hello, Math 2 students. The first thing that I want you to do today is look at this picture on the screen. And I'm going to ask you a few questions about these vocabulary words that we use every day. The next thing that I want you to consider is this problem here. Find the zeros of the function f of x equals 2x squared minus 32x plus 110. You should write this problem down on a piece of paper, and as we work the next two examples, be thinking about what the answer to this problem is. And at the end of the video, I'm going to ask you for the zeros of this function. On this example, we need to use zeros to graph y equals negative x squared minus 6x. The first thing I notice about y equals negative x squared minus 6x is that it doesn't have any parentheses. So I know that this function is in standard form. And I know that my a value is negative 1. I know that my b value is negative 6. And I know that my c value is 0 because there's no constant term at the end of the function. So I do know, because the c value is 0, that my y-intercept will be 0. But it says I need to graph this by using the zeros. So the way that you can find the zeros is you need to find the x-intercepts. And to find the x-intercepts, we need to put this function into intercept form. So when I look at this problem, I can see that my a value is negative. So I know that I'm going to have a greatest common factor that is negative. And when I look at both terms in the function, they both have at least one x. So my greatest common factor on this problem will be negative x. Now, in order to figure out my remaining binomial that'll be left over in the parentheses, I can just divide each term of the standard form function by negative x. So negative x squared divided by negative x is positive 1x. And negative 6x divided by negative x is positive 6. Now, the function is in intercept form. And if I take intercept form and I find out which values of x will cause the function to equal 0, I will find out the x-intercepts. So when you have an x in the front of the parentheses, you know that you'll have one x value of 0. And inside the parentheses, we don't have any coefficient in front of the x, so we can just use the opposite. So x will equal negative 6. So our x-intercepts are equal to 0 and negative 6. So when I go to my graph, I'm going to put one x-intercept at 0 and one x-intercept at negative 6. So I have 2 points on my graph so far. In order to make the entire parabola, I'm going to need to find at least another point. So I'm going to look for my axis of symmetry first of all. I think I could draw it in just by using the graph, but I'm going to go ahead and calculate it anyway by using the formula x equals p plus q divided by 2, where p and q are your x-intercepts. So we'll have 0 plus negative 6 divided by 2. And 0 plus negative 6 is negative 6. Divided by 2 is negative 3. So my axis of symmetry will be at x equals negative 3. And when I draw that in, it should look like this. So there's my axis of symmetry. Now, to find my vertex, I need to take my axis of symmetry and I can put it back into the intercept form equation, or I can put it back into the standard form equation from the beginning of the problem. On this problem, I think I'm going to use the standard form equation. So that's going to be y equals negative empty bracket squared minus 6 empty bracket. And in those empty brackets, I'm going to put my negative 3, or my x coordinate of my vertex. And so I need to go in the correct order of operation. So first, there's no math problems in parentheses, so I don't have to worry about that. But I have to do exponents second. So I have y equals negative 9 minus 6 times negative 3. Now that I've done the exponents, I'm going to take care of the multiplication. So y equals negative 9 plus 18. And negative 9 plus 18 is 9. So the y coordinate of my vertex is 9. So if I go 3 to the left and up 9, that is where my vertex will be. So now that I have 3 points, I'm going to draw a smooth parabola that goes through all 3 points. And one thing that makes sense about this problem is we knew that our c value was 0 at the beginning, and that's the y-intercept. And it turns out that is our y-intercepts. We have an x-intercept at 0, and that same exact point is also the y-intercept. So that is how you can graph a parabola by using the zeros of the function. On this example, we have the function h of x equals 2x squared minus 22x plus 56, and it's not asking us to graph it this time, it's just asking us to find the zeros. What are the values of x that will turn the expression 2x squared minus 22x plus 56 into 0? So to start that problem, I'm going to write it just like that. 0 equals 2x squared minus 22x plus 56. And I want to know what value of x makes the right side equal 0 to match the left side. What are the zeros? So when I look at 2x squared minus 22x plus 56, my a value is 2, my b value is negative 22, and my c value is 56 in standard form. So to find the zeros, I need to put this thing into intercept form. And when I look at my 3 terms, they're all even numbers. So I know there's going to be a greatest common factor of at least 2. And since the a value is 2, I think 2 is going to be my greatest common factor. So I'll write 0 equals, and then I'm going to have a remaining trinomial when I'm done. And if my greatest common factor is 2, that is the biggest number that goes into 2 and negative 22 and 56. So now if I take every term in my trinomial and I divide it by 2, that will tell me my remaining trinomial in the parentheses. So 2x squared divided by 2 is x squared. Negative 22x divided by 2 is negative 11x. And positive 56 divided by 2 is positive 28. So now inside my parentheses, I have a trinomial that has an a value of 1. So this problem just got a lot easier. I just need to find 2 numbers that multiply to 28 but add up to negative 11, and that will tell me my binomial factors. So I'll have 0 equals 2, and then I have my binomial factor. Since my a is 1, I know I'm going to have an x here and an x here. I just need to find the 2 numbers that multiply to 28 but add to 11. So the possibilities could be 1 times 28. It could be 2 times 14. It could be 4 times 7. And those are the possibilities. Those are all the ways that you can multiply and get 28. Now, 1 and 28 is not a good choice because that could add to 29 or subtract to 27, but there's no way that it's going to make negative 11. With 2 and 14, it could add to 16 or subtract to 12, but there's no way that it's going to come out to negative 11. With 4 and 7, it could add to 11 or subtract to 3, but the part that we really like about it is it can add to 11. So we know we're going to use 4 and 7 in our binomial factors. Now we need to look at the signs. Since our c value is positive 28 in the parentheses, we know that our signs are going to be the same. So if we're going to multiply 4 and 7 and get 28, it's either got to be negative 4 and negative 7 or positive 4 and positive 7. Now, because our b value in the parentheses is negative 11, we know our signs are going to be the same and they're both going to be negative. So those are our binomial factors. If I FOIL quickly to make sure that I did the problem correctly, x times x is x squared. My outers are x and negative 7, so that makes negative 7x. My inners are negative 4 and x, that makes negative 4x. And my lasts are negative 4 and negative 7, which makes positive 28. And then the thing that lets us know that we did the problem correctly is that negative 7x and negative 4x come out to negative 11x. So we've just changed our function from standard form into intercept form. Now that it's in intercept form, all we need to do is find our x-intercepts, or our zeros, and we'll be done with the problem. In front of our x in the first binomial, in the first set of parentheses, there's no coefficient. So we can just use the opposite. So one of our zeros will be x equals 4. In the second set of parentheses, we have x minus 7. There's no coefficient in front of the x, so we can just use the opposite. So it's going to be x equals 7. So in this problem, they ask us to find the zeros of the function. What are the two x values that will make our function equal 0? And the two x values that will make our function equal 0 are 4 and 7. Now, back to the problem from the beginning of the video. I told you that you should write this problem down, and as you watch the two examples, try to figure out how you're going to find the zeros of this function. So right now, make sure that you have those answers right and answer the question at the end of the video.